All right, so perimeter area and volume is going to be our next unit. You are probably already familiar with perimeter area and volume. So we're kind of getting into an extension of these topics. Okay, so perimeter is the distance around the outside of an object. Typically in the past, you are probably familiar with just adding up the sides or counting the little boxes on the shapes. But the key word there is around. Okay, so perimeter is the distance around the outside of an object. Okay, so if you look at this picture up here with the fence, if you were putting a fence around your garden, or if you needed to put a pen for your animals to enclose them in the yard, you would need to find the perimeter of that space. Okay. Same thing here. If this little mouse roller skated all the way around this rectangle, that would be an example of perimeter. And this is probably how you are familiar with perimeter from like 3rd and 4th grade. So you would count the boxes that are around this shape. Okay. So let me see here. Typically what you would do for perimeter is you would count this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would have a perimeter of 14 units. Thomas? You do count the corner boxes twice with perimeter. So it would go like this. Let me erase that. That's a good question. So you would say that this box has on this side 4. Okay, so that would be 4. This would be 3. So you are counting this side and this side of that box. And then, of course, you would have 1, 2, 3, 4 again this way, and then 3 again this way. So that would be a total of 14. 4 plus 3 plus 4 plus 3. Now, when we're talking about rectangles, there is something called a formula that you could use, and we will talk about that in the next couple of slides. Okay. So, all right, let's move on to area. Area is a 2-dimensional space that covers a flat surface. Key phrase is going to be covers a flat surface. So area is 2-dimensional. It's flat. It only has 2 dimensions. In the case of this rectangular backyard, I guess, inside the fence is the area. So it has a dimension of a length and a width, similar to this up here. Okay, same shape, rectangle. So we would say the area that's inside the fence, that's flat, the grassy area is an example of area. Let's see here. Okay, you might be familiar with this when you had talked about area maybe in 3rd or 4th grade. You just counted up the squares. Okay, so that creature right there, that little critter, if you counted up all those squares that were colored, that would be the area of that shape. You would just say square units. Okay, question?
It looks more like some sort of mole.
A mole?
It's like a monkey.
Yeah, it's like, I don't know, it's a squirrel or chipmunk or who knows what it is. It does kind of look like it could be a monkey. So again, this is another example of area. So if you had to find the area of this rectangle, all you would have to do is count up those blocks. Okay. But what happens if we have a rectangle that has dimensions of 183 by 62? Are you going to sit there and draw that many lines and boxes inside your shape? Absolutely not. So we have formulas, or a formula is kind of like a recipe for finding the area and perimeter of certain shapes, especially when you get into things that have larger numbers, okay? Volume is three-dimensional. So when we're talking about volume, we are talking about things that have three dimensions, or typically things that fill an object, okay? So perimeter is around the outside, area is covering a flat surface, volume is something that fills an object. You could have the volume of the air in a box or water in a pool. A lot of the times you'll see images like this. Okay. If you have a Rubik's Cube, all right, if you counted up all the cubes in that Rubik's Cube, you would have the volume in cubic units. You cannot see all of the cubes, though, just by looking at the shape, okay? So the volume of a rectangular prism, if we're looking down here at this gray rectangular prism, if you think about the bottom layer, and I'm gonna kind of highlight that with my pink pen. If you just think about that bottom layer, okay, you have, let me erase that and I'll put them in. You have three little dots, or I mean, not three little dots. You have three cubes here. 1, 2, 3. Okay, so it's 3 going this way. And then you have 1, 2, 3, 4 going that way. So just in that bottom layer, you have 3 rows of 4. Even though you can't see all the cubes, they're under there. So in that first layer, you have 12. So 3 rows of 4, or in other words, we found the area of the base. This would be called the base of that prism. Okay, so the bottom layer, or the base, is 3 by 4. 3 rows with 4 cubes in each. So the bottom layer is 12. And then how many layers are in the prism? That is the height. So we would say the height is 1, there's 1 layer, 1, 2, 3, 4, 5. So it's 3 by 4 by 5. So then if you take 3 times 4, that's 12. 12 times 5 is 60. This entire prism has 60 cubic units in it. 60. Okay, and that's how you would figure that out. We can't see them all, but we can envision it in layers. But there is a formula for finding the volume of a prism. Thomas? If you took it apart, there would be 27 in there. Inside of it? I haven't ever taken one apart before.
Is this like the mysteries we did in the beginning of the year, but not estimated?
Say that one more time.
Is it like,
Did I give you prism ones?
no,
Like with cubes?
but like guessing the ones that are inside of it, like.
Sort of. But there is a formula. Now, if your shape is not a prism, then there's different methods of getting the volume. We could talk about that later on this week. But for the most part, you will be finding the volume of rectangular prisms. Now, if your three-dimensional object was not a rectangular prism and it was a different shape like a cylinder, you would have a completely different formula to find the volume. Okay, because if you think about the prism, what shape is the top and the bottom of your prism? What makes up the base? Squares or rectangles, right? If you had a cylinder, your bases are circles. So there's a different formula for circles, which is a completely different unit that we will be getting into in the next couple of weeks. So stay tuned for that. All right, so we're focusing on squares and rectangles, rectangular prisms, things like that. All right, so here's an example of a rectangle that has dimensions that are 9 yards by 6 yards. So what that means is your length and your width. And sometimes people get confused with length and width and which one is which. In this case, it doesn't really matter. I typically say that the length is the longer side, but it kind of just depends on how you are looking at your shape. So I would say that the length of this rectangle is 9 yards and the width is 6. So I know that L is going to stand for length and W is going to stand for width. Okay. And because this is a rectangle, we have a formula for finding the area. This is the formula for finding the area of a rectangle every single time. Okay. So the formula for finding a rectangle, if it is a different shape, it's going to have a different formula. All right. So we would just, what is LW? When they're smacked together, okay, and they're side by side, what does that mean? What operation does that mean? Anybody? Multiplication. So that means when you have the two letters next to each other, that means multiply. So we're simply going to multiply the length times the width. In other words, this would look like this. All right, we would have 6, 1, 2, 3, 4, 5, 6 by 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all together inside that space, we would have 54 square units. Okay, now, wasn't a big deal to draw in those lines. But when you get, what happens if you had decimals as your dimensions? Then we would be getting into a whole different ball game of what your lines would look like. So when you have a formula, it's much easier to use the formula. So 9 times 6 is 54. So we would say 54 square yards like this. You could abbreviate it like this, but you will mostly see it abbreviated like this. You will have yards, and then you will have a little 2 up there, okay? So that little 2 right there means square yards, okay? The perimeter of this shape, now we can have a formula for this, which they give us a formula up here. Let me make this a different color. All right, here's the formula for perimeter. Now, I simply can say 9 plus 6 plus 9 plus 6, right? Because I know that this side is 9 and then this side is 6. It's a rectangle. Rectangles have opposite sides that are congruent. So I could easily say 9 plus 6 plus 9 plus 6. I could also say 9 plus 6 is 15. Well, then the other two sides have to also equal 15, correct? 15 and 15 is 30. Okay, so I know that my perimeter is going to be 30. This formula up here, all right, says 2L, which means 2 times the length, plus 2W, 2 times the width. So if we take 2 times L and we plug in 9 for L, that's going to give us 18. 2L or 2, 9, like that, would be 18. And 2, 6, 2 times 6 is 12. And together that makes 30. Or you could take 2 times 9 plus 6. And so therefore you would have 2 times 15, which is also 30. Okay, so there's lots of different ways to figure out the perimeter of a rectangle. All right, now the units. All right, area units are always squared. Perimeter units are just plain units because we're just talking about one dimension. We're simply talking about one distance all around. Okay, so your units, let me get rid of some of this stuff. All right, we said 54 square yards for our area, and the perimeter was going to be 30 yards. Nothing fancy to add to our units. It's just yards for perimeter. Area will always be square units. So if you're talking about inches for area, it would be square inches. If you're talking about feet, it would be square feet. Okay? All right. Whoops, didn't want to click on that. All right, next. So we have a square here. How do I know it's a square? Because they only give me one side. So it is safe to say that if this side is 5 and there's no other information here, then all of these are going to be 5 centimeters. So my area is going to be length times width. So length times width, and that would just simply be 5 times 5, which is what? 25, and our units are centimeters. And what do we do with our units when we were talking about area? We square them. Okay. Perimeter is going to be adding up all the sides, or you could say 5 times 4 in this case, or you could say 5 plus 5 plus 5 plus 5. These two make 10. These two make 10. There's 20 centimeters. And we leave our units alone when we're talking about perimeter. Okay. All right. Next. All right. We will get into triangles a little bit later. That's a whole nother, it's a different formula because it's a different shape, but it is related to rectangles. So just keep that in the back of your minds. And we will get to that later this week. All right, another triangle. Okay, let's talk about volume. So volume is 3-dimensional. Okay, area is 2-dimensional. Volume is 3-dimensional. So we have length, width, and a height. So in this case, Emily's Valentine's box is 10 inches long. So from there to there, it's 10. It is 5 inches wide. So from here to here is 5. If I just multiplied 5 times 10, what would I get? 50. So if you imagine that base layer of cubes, okay, there would be 50 cubes in the base layer. All right, it would be 5 rows of 10 or 10 columns of 5, however you wanted to say it. So 5 times 10 is 50. So there's 50 cubes in the first layer. It is 3 inches tall, which means we have 3 layers of 50. Let me put the 3 here. So 3 layers of 50. So we've got 5 times 10 times 3. Here is your 50, and we are going to have that layer 3 times. So 50 times 3 is 150. Our units for volume, we would say we're talking inches. Okay. Are we talking about flat squares? We're talking about 3-dimensional cubes. So your units for volume are always in cubic units, which we represent with a 3. You could also say cubic, which is abbreviated CU period, and then inches. Okay? All right. Then, so that's just a little example of volume, which we will definitely be practicing with that more later this week as well. So the other part to this unit is being able to determine whether you need to find the perimeter area or volume. So if we were talking about replacing this glass window pane that Gavin broke with his baseball, if we had to replace this glass window pane, would we need to find the perimeter area or volume for the glass? Think about that. Perimeter is the distance around. So think about things that have a border. Okay, are we just putting a border of glass in there? Are we putting an entire flat piece of glass in there? Or are we putting or are we filling that space with glass? Sully? Yes, we would be finding the area of that space. And so we would just multiply 12 times 14 to get that. Okay. Josie's daily walk. If she starts here at her house and she goes to school, then from school she goes to the library, and then from library she goes to her house, and we want to know the distance, we would be finding the perimeter. Okay. Anytime you're talking about cubes or anything that's three-dimensional, she had bought some centimeter cubes and they came stacked very carefully in a box. So how many cubes were in the box? That would be an example of volume. Okay. If you were putting a sail on a sailboat, you would have to know how much fabric to buy. That would be, are you filling the sail with fabric? Are you just putting fabric around the edge? Area. Anytime you're talking about something that is flat and that covers something, you're talking about area. All right, I'm going to skip ahead a little bit and we will practice this. Okay. If you were replacing the carpet on the floor, you would need to find the, are you filling your room with carpet from floor to ceiling? Are you just putting carpet around the outside edge? You would need to find the area. If you're covering your floor with carpet, that's area. If you were figuring out the amount of orange juice in a carton, volume. Fence around a playground, perimeter. Painting a wall, area. Wood trim on a picture frame, perimeter. Cereal in a box, volume. White line bordering a soccer field, perimeter. Wooden surface of a table, area. Good. Lacy sewed around the edge of a pillow, perimeter. Glass in a window, area. Gasoline in a tank, volume. Cake in a birthday cake, volume. Cloth in a bed sheet, good. Air in a box, blocks in a Rubik's cube, volume. Grass in your yard. Are we just planting grass around the edge and the rest dirt? We got area for that. Okay, you're covering your whole entire yard. Paper to make a poster, area. Bulletin board edge trim, good. Rug on the floor, and you ever notice that it's called an area rug? Okay, and ice cream in a box, volume. Okay, good. What's that? A box of ice cream? Ice cream always comes in a box. It's cardboard covered in wax.
Why do I eat ice cream? Exactly.
Well, it's waxy so that it doesn't like leak. So it doesn't leak. Okay. Anyways, we will continue with this this week and next week. So stay tuned for more videos and information. Don't forget to like and subscribe.